is a quadrilateral while opposite sides are what? Parallel. By definition, opposite sides are parallel. Opposite sides in a parallelogram are also what? Congruent. They're parallel and they are congruent. A rectangle, by definition, is a parallelogram with 4 right angles. What do we also know about their opposite sides? Also congruent. A rhombus is a parallelogram with all 4 sides that are congruent. All 4 sides are the same. All 4 sides are congruent. And a square is a parallelogram with 4 sides that are congruent and 4 angles that are right angles. So their sides are congruent and all the angles are right angles. So this info is kind of helpful when we're trying to find the symmetry of these different types of quadrilaterals. So if we take a look at this rectangle, we're going to draw in all the lines of symmetry. To help you figure out the lines of symmetry, think, how can I fold this figure and it will map up perfectly onto itself? How do we think we can fold this? To draw our lines of symmetry. Is that right? Yeah, up and down, right down the middle. We can draw this line of symmetry. Where else can we draw a line of symmetry? Across, horizontally, right down the middle. Can we draw any other lines of symmetry? No. Some people think that diagonal. Why does the diagonal not work? Yeah, it won't match up. When we fold, we're folding along that diagonal line. So this long side would match up with this short side. Does the long side match up perfectly with the short side? No. So the diagonals do not work in a rectangle. So the only lines of symmetry that a rectangle has are vertically through the middle and horizontally through the middle. That is it. Diagonals do not work with rectangles. So it doesn't matter how big or how small the rectangle is, those are the only lines of symmetry you can draw in any rectangle. What about a rhombus? Diagonal. Yeah, the diagonals work in a rhombus. So this is a line of symmetry. This is also a line of symmetry. Are there any other lines of symmetry? No. Up and down and across don't work in a rhombus because the angles are all different. The reason why up and down and across works in a rectangle is when we fold across, the angles are going to match up perfectly. They're all right angles. But if we were to fold along this line in a rhombus, this horizontal line, we were to fold across that, this angle would match up with this angle. And are those angles the same? No. So is it going to match up perfectly? No. So that's why across and up and down don't work for a rhombus. The only ones that do are the diagonals. Didn't want to clone that. That's why the diagonals work, because the sides are the same and the opposite angles are the same, so everything would match up perfectly. Questions over that? Oh, we forgot to say this has 2 lines of symmetry. And a rhombus also has 2 lines of symmetry. And that's it. Questions over that? To help us with the next one, to help us with a square, we said a square is a type of what? Parallelogram. It's also a rhombus and a rectangle. Well, if it's also a rhombus, what lines of symmetry will a square have? Diagonals, right? Every rhombus, the only lines of symmetry it has are the diagonals. So for a square, the diagonals are going to be lines of symmetry. Well, if it's also a rectangle, what else are its lines of symmetry going to be? Up and down and across. So how many lines of symmetry does a square have? 4. If you also recall from Unit 4, a square is a regular quadrilateral. All the sides are the same, and all the angles are the same. So the number of lines of symmetry it will have is equal to the number of sides because it's regular. So a square has 4 sides. It's going to have 4 lines of symmetry. What about a parallelogram? Any way we can draw any lines on a parallelogram? No. Parallelograms, regular old parallelograms have 0 lines of symmetry. Because there's no really big special trait about them. Rhombus, all 4 sides are the same, so things can match up. Rectangle, all the angles are the same, so things can match up. There's nothing like that with a parallelogram. So all regular parallelograms have 0 lines of symmetry. You cannot draw any sort of line and fold it, and it will map up. So rectangle has 2, vertical and horizontal. A rhombus has 2 lines, it's the diagonals. Square has 4 diagonals and across. And then parallelogram has 0. So now we're going to talk about rotational symmetry. Okay? With rotational symmetries, that's how many times we can rotate a figure and it maps up onto itself. And we're rotating about the fixed point of the center of the figure. So how many times do you think we can turn a rectangle and it maps up onto itself? Twice, right? Turning it, turning it, turning it. There's 1 turn and it maps up. And we're back to the beginning. That's 2 full turns and it maps up onto itself. So that means the order is 2. If you remember from Unit 4, the order is how many times you can rotate it. So we can rotate it twice. Do you remember how we find the angle of rotation? And someone say very quietly, 360 divided by 2. You do 360 divided by the order, and that will give you the angle of rotation. That's how many degrees you can rotate a figure, and it maps up onto itself. What is 360 divided by 2? So every time we turn it, that's 1 turn from the start to here. That was 180 degrees. From here to here, that's another 180 degrees. What about a rhombus? How many times do you think we can rotate that and it maps up onto itself? 2 times. There's 1. There's 2. So what is our order for a rhombus? 2. That's how many times we can rotate it. And if it has an order of 2, what's the angle of rotation? 180. 180. Put your degree symbol. Put your angle. And 360 divided by 2 gives you 180 degrees. Questions over that? For a square, how many times do you think we can rotate a square and it maps up onto itself? 4. Yeah, it's a regular figure. All sides and angles are the same. It has 4 sides, which means you can rotate it 4 times. There's 1, 2, 3, and 4. So the order is 4. What is the angle of rotation? What do we get when we do 360 divided by 4? 90. So every time we rotate it, we're rotating it 90 degrees. There's a 90 degree turn. There's a 90 degree turn. Another 90. Another 90. What if we did 3 90 degree turns? 1, 2, 3. How many total degrees is that? 2, 7. Okay. If we did 2 90 degree turns, how many degrees is that? 20. keep that in mind for your practice. And then how many times do you think we can rotate a parallelogram? What do we think? Let's see. Did that work? There's one. Back to the beginning. 2. So the order is going to be 2, which means its angle of rotation is 180. Half of 360 is 180.
Wait, why are we doing this here?
So we're doing what?
The rotations again.
Because we're doing it with the quadrilaterals. We didn't do quadrilaterals when we did it back in Unit 4. We needed to learn about them to kind of understand why it works. And it's helpful to go back and just redo things so we don't forget. Other questions? So you flip it over the back. We're going to take a look at how this looks in the coordinate plane. Okay. So take a look at example 3. It says a rectangle is graphed below. Determine which of the following transformations would map a figure onto itself. So whenever you're seeing the directions about mapping a figure onto itself, you're looking for symmetry. Okay, when it's talking about reflecting over a line, that's line symmetry. When it's talking about rotating a figure, that's rotational symmetry. So I like to go through and do my reflections first. So I'm going to go through, try A, B, C, and F, or E and F first, and then deal with the rotations second. So all I'm going to do is just highlight the line it's telling me, the y-axis. Here's the y-axis. I'm going to draw it in on that rectangle. And then I'm going to ask myself, is that a line of symmetry? Yeah, so is that an answer? Yeah, if we reflect it over that line, it will map onto itself because it's a line of symmetry. If it's not a line of symmetry, then it's not an answer. What about the line y equals x? Let's draw it in just to get a visual if you can't visualize it. When we graph the line y equals x, where do we start? 0. Yeah, the origin, and then we're just going to go up and over. Up 1 over 1. When we draw in that line, is that a line of symmetry? No.
No.
Okay? Not an answer. Before you even drew that line, if you can visualize what y equals x when we graph it, it's slanted, right? And do slanted or diagonal lines ever work for lines of symmetry in a rectangle? No. So if you realize that, you can rule that out right away. Which one else is a no? E. Because if y equals positive x doesn't work, y equals negative x doesn't work because it's slanted. Slanted lines don't work for rectangles. That would make it a diagonal. And then what about a reflection over the x-axis? Will that work? Is that a line of symmetry, the x-axis? Yeah. So that is an answer. Line of symmetry, yes. Not a line of symmetry. So now, between C and D, the rotational symmetry. What did we say is the rotational symmetry for a rectangle? 180. So our answer has to be what? 90 is not its angle of rotation. All rectangles can only be rotated 180 degrees for it to be mapped onto itself. If you don't remember, just turn your paper, figure out how many times can I rotate this. I can only rotate it twice. So 360 divided by 2 gives me 180. But if you can just remember that fact, oh, it's a rectangle. It's 180 degree rotation. That's my answer. Questions over that? If we take a look at example 4, we have a parallelogram. That's graphed below. We're going to determine which of the following transformations would map the parallelogram onto itself. Well, what do we know about line symmetry? I always do my line symmetry first. What do we know about line symmetry of parallelograms? Does it have any?
No.
No. So can we reflect it over any line then?
No.
We can lines over lines and it maps onto itself because there's no line symmetry. So we can rule out C, E, and F. Those can't be an answer. Well, what degree can we rotate all parallelograms? 180. So the only answer we can have is what? C. So yes, it said select all that apply. And we only selected one. That's okay. There's only one that applies. It's very rare that that happens, but it might sometimes. Very rare though. I feel like they were just making a whole. Yeah, one more. 5, we have a rhombus that is graphed for us, and we need to figure out what we can do to get it to map up onto itself. So that means I'm looking for symmetry. I like to do my line symmetry first. So go through, highlight my y-axis. Is that a line of symmetry for that rhombus? No, so it's not an answer. What about reflecting it across YW or WY? Is that a line of symmetry? Yeah, because it's a diagonal. Diagonals are the only lines of symmetry for a rhombus. What about XZ? Yeah, again, because it's a diagonal. And diagonals are the only line symmetry in a rhombus. No other lines will work. What about the rotational symmetry? All rhombus has a rotational symmetry of what? 180. So we can rule out A. The problem is we have two answers that have 180 degrees in it. We have to think about which one would work. Which one is it? C, about the center of the figure. Okay. So whenever they give you both options, you always want to pick the one where it says the center of the figure. The only way rotating it about the origin works is if the figure is centered at the origin. Well, here's roughly where the center of this figure is. That green point right there is at the origin. No. Yeah, the origin's at 0, 0. So rotating it on the origin won't map it up onto itself because that's going to rotate it around the coordinate plane. So like if we were rotating X about the origin, 1, 4. When we rotate something 180 degrees, what do? What's the rule? Do we flip? No, we just change the sign of both. So that becomes -1, -4. X did not map up on another vertex. So rotating about the origin when it's not centered at the origin is just moving it to a different spot on the coordinate plane. Rotating about the center of the figure, well, that's the fixed point that it's centered at. So it's just going to kind of stay where it's at and just turn right here. That's rotating about the center of the figure. So it's going to rotate, rotate, and keep mapping up onto itself. The only time when it says centered at the origin is when the figure is centered at the origin. The only time that will work. Questions over that?
Posted on